Alright, in this section here we're going to be talking about the Cartesian coordinate system, also known as the rectangular coordinate system. And I need to get started with drawing a picture. So let me do that. And yes, I could bring up a nice fancy graph, but you know, there's just something about sketching it by hand I feel gets the point across a whole lot better. So I'll draw as straight as lines as I can here. This is going to be known as the rectangular coordinate system, or also known as the Cartesian coordinate system, and that's what I've got. That's what I've got spelt up here. The way this works is this thing is made up of an infinite number of ordered pairs, or I should say there's points. There's an infinite number of points in this coordinate system. Now I'm going to consider that this be the real number line and this up here also be the real number line. Now I'm going to plot a point here on the, and usually we call this the x-axis, and this is the y-axis here. So let's say I located 1 on the x-axis and I located 1 right here on the y-axis, and right here, this point where you go up 1, you go starting at the origin, you go over 1 and up 1. This point right here, okay, its address is going to be 1, 1. Now this is known as an ordered pair. It's a pair of numbers and it's an ordered pair because this number here comes from the x-axis and this number is coming from the y-axis. Alright, this is known as the first coordinate and that's known as the second coordinate, and they do have fancier names, but we're just going to leave it at that right now. Alright, let's say I picked a number down here. Okay, this is 0 right here. So it goes 0, 1, and then we'd say 2, and then 3, and so forth. And then this going in this direction would be -1, -2, and -3. Okay, so anyway. So this ordered pair right here, this point's address, it would be over 3 and down 3. So you see every point in the Cartesian plane has an address. Now let's say, for example, we were talking about points that were just in this side of the coordinate system. Okay, now each one of these has a name, and the name of this side is quadrant 1. So everything over here in this side of the coordinate system is quadrant 1. This side is quadrant 2, and this side is quadrant 3, and down here this is going to be quadrant 4. Okay, quadrant. Let's erase this picture and let's start over. How's that? With a new picture. So I'm going to try to draw some straight lines here. I'm going to give a set A. This set is going to consist of some ordered pairs. Let's say 0, 0, -1, 3, and let's say -2, -2. Alright, I ran out of room there. So let's graph this. So here's a point. I'm going to use, actually let's use some different colors here. So 0, 0 we'll say is here. -1, 3. Now I'm just going to guess. Here's -1, let's say, and then we go up 3. So there's -1, 3, and then the next one's -2, -2. So that's, we said that was -1, -2, and -2, which would be somewhere about right here. Okay, so here's our 3 ordered pairs. Okay, so we graphed out this set of ordered pairs. Now let me show you a special set that we'll be talking about in the next section, but we might as well, since we're talking about it, might as well get this out of the way, or at least mention it. Alright, so I'm going to attempt to draw an X and Y axis here. Right, our X axis and our Y axis. If I had the set, we'll call it A again. Why not? If I had the set, for example, 0, 1, 1, 2, and 1, 3. Alright, we'll just, that's supposed to be curly braces there, curly brackets. Okay, so we plot our points. Let's give them a different color here. So here's 0, 0. This is going to be 1, 2. So 1, 2 we'll say. And that is not supposed to be a 1, because this is supposed to be a special set. Let's make that a 2, 3. How's that? A 2, 3. We'll go over, let's see, 0, we'll call this 1, and this 2, and this was going to be 2 here. Yeah, this is definitely not to scale, but anyway. And so 2, 3 is going to be about right here. Okay. Well, this is a special set. This is a function. Okay. And we're going to talk about that here in the next section, what functions are. But this is a set of ordered pairs, but it's a special set. Okay, in a previous section we talked about linear equations, and I'm going to now put a picture to a linear equation so you can actually see what a linear equation actually looks like. So let's go ahead and draw a rectangular coordinate picture, and let's work with y is equal to x plus 1. So this is a linear equation, and what we're going to do here is, now I guess there's something I hadn't mentioned, but you know, this is the real number line. Even though I'm just plotting 1, 2, 3, 4 and so forth, you know, a half is in here, square root of 2 is in here, pi is in here, you know, 12/13 is in here, but we're just working with integers right now. And if I say integers, I need to throw a negative in over here, because really what we've been working with are just pretty much whole numbers. Anyway, I'm going to graph this. This is numbers that go in for x, right? Remember, is this first coordinate, and then the numbers that come out, well, I say, are go in for this coordinate. And so usually the way sometimes we learn how to graph these things, we'll just do a couple numbers here. Okay, so this is our x's and this is going to be our y's over here. So if I were to plug in 0 into this, 0 plus 1 is 1. Plugging now 1 into this, 1 plus 1 is 2. Then we plug 2 in, 2 plus 1 is 3. Plugging now 3 in for x, 3 plus 1 is 4. Now let's say that I'm going to now write, I don't know why I'm calling it A again, but I'm going to write all my ordered pairs in this set. So 0, 1, okay, then 1, 2, 2, 3, and 3, 4, and I'll have to come down here on that. Okay, so 1, 2, 3, 4. So I just selected some points. You know, there's an infinite number of these points, especially if we're in the real number system. But we're just trying to get an idea maybe of what does this graph look like. So 0, 1, and of course I want to use some different colors here. 0, 1. So we're at 0 and we go up 1 unit. Right, so that's this ordered pair here. It's where this ordered pair is located. Then 1, 2, over 1, up 2, we'll say right here, and then 2, 3, over 2, up 3, okay, we'll say here, and then 3, 4, so we'll say 3 is right here, and then up 4 is right here. And of course, I have just, you know, 4 ordered pairs here. But if we were looking at this as all real numbers are plugged into X, in other words, every single number, of course, you know, I can't write out all that, all those ordered pairs. I just selected a few of them here, or 4 of them. But if I were to draw a line, and I don't know, we'll just keep it green here. How's that? If I were to draw a line through these points, and I'm going to try to make it a straight line the best I can. And I should say that it would be crossing right here at -1. Okay, so this is an infinite number of points. In other words, if I were to take this number here and plug it in for X, we'd get a Y out. Right, and you know, if you did every single point on the number line, which we can't, okay, we'd end up getting what looks like a straight line here. That's supposed to be a straight line. Alright, so this is just an idea of how to take this equation here and represent this equation by its graph. I think what I'll do next is actually show a graph. We're going to use a Google graphing calculator, and I'm gonna let's just do that. Let me bring that up. Okay, so what I did was I went up to the address bar in my Chrome web browser and just typed in x plus 1, and this is one of Google's tools here, graphing. That's great. It's great for graphing. Of course, we got a tracer here, and then it shows our coordinates up here. So remember, we had 1 and it was 2. Now it's hard to get this exact up here. You know, I'm trying to get it about exact as I can. But as you can see here, this is a straight line. Right? Straight line. Important things, it passes through the y-axis at 1, and it passes through the x-axis at -1. So these are going to become some really important things that we talk about later, and that are things that are called y-intercepts, where it crosses the y-axis, and x-intercepts, where it crosses the x-axis. Okay, so now in intermediate algebra you have definitely hit a different dimension, and that is we're able now to draw pictures with things that we're working with, and it's a really helpful tool. We can thank, I believe it's Rene Descartes, I do believe, the inventor of the Cartesian coordinate system, also known as the rectangular coordinate system. I'm going to actually add, what happens when I add 1 to this? In other words, x plus 2. Let's see what happens. Well, what has happened here, if you look at the y-intercept now, the ordered pair is 0, 2. So take notice up here. Our ordered pair, when we plug 0 in, we get 2 out, right? So if I plug 0 in for x, 0 plus 2 is 2. So we get 2 out. And the other one that I just had, the previous one, the y-intercept was 0, 1. So we added 1 to this, and what happened was it took this graph and it shifted it up 1 unit. It shifted it up 1 unit. Isn't that neat? Keep your eye on the blue ball. You are now going to sleep. Alright, in this one here I'm going to attempt to graph this, or graph some points, and then we'll actually bring up a graph on the Google page. So what I'm going to do here is I'm going to start with, for example, we'll start with -1 in this particular case. So we're going to let x be -1 and y is equal to x squared. In other words, we're going to square -1. I guess I'll just show that right here, and that becomes 1. So -1, 1. So we're going to plot that point right there, and then we plug 0 in. 0 squared is 0. So then it's passing through the origin. This is the origin here, and kind of running out of room here. Plug 1 in. 1 squared is 1. So the other ordered pair is 1, 1, so that's going to be about right here. So there's going to be some symmetry involved. Plug 2 in. 2 squared is 4. Alright, so let's say this is 1 here, and we go over to 2, and then we would go up to 4 up here. Okay. Anyway, if I were to write this as some ordered pairs, our first ordered pair was -1 and then 1. So that's this address here. Then our other one was 0, 0, and we had another one, 1, 1, and then we plugged in 2 and we got 4 out. So this is just 4 points here, right? Now remember, if we're using the real number system, there's an infinite number of points. Then we could sketch this thing out, and it's something like this. Boy, that's a rough sketch, let me tell you. Let's actually look at it on a graph, on a real graph. Okay, isn't this much prettier? So this was 0, 0, and this was, as you can see, remember our coordinates are up here, so I'm going to go to -1. And remember, at -1 it was 1, and then at 1 it was 1, 2, I think we just stopped at 2, it went to 4 here. But you can see the shape of what that equation looks like. Y is equal to x squared. Right, isn't that pretty? That's called a parabola. This particular curve here is known as a parabola. Alright. Okay, well, hopefully you're getting the idea of graphing an equation. So we talked about these two lines here, the y-axis, the x-axis, and of course remember there's an infinite number of points on both the y-axis and the x-axis here, even though I've only been plotting just a few points here. So this is kind of a review. Remember, this is the quadrant 1, this is quadrant 2, quadrant 3, this is quadrant 4. Okay, this is known as an ordered pair. This is your first coordinate, and this is your second coordinate. And the first coordinate here, we normally call this the x coordinate, and this is the y coordinate here, because this comes from the y-axis. Right. So there's a lot of power behind being able to draw a graph with its equation. And of course, sometimes we don't just have equations, we might just have some data, and we want to plot our points on a graph to kind of look at our data visually, which is really important. Well, the next section is on relations and functions, and that's what we're going to get to next. This is particular one, of course you can't see it up here, this y is equal to x squared. These last two, these are what are known as functions, and of course we're going to get into a lot of detail in that because that's extremely important, this idea of a function, which is actually a relation in more a general sense. In a more general sense, it's known as a relation, but a special kind of relation is called a function, and we use a lot of it in mathematics, so you really want to get that understanding down. Alright, have a good one.